Another alumni from Uppsala University is the CTO and temporary CEO of Altris, a spin-off company focusing on sodium-ion batteries. So most welcome here and welcome back, Tim. We have expanded the building since you were here last time.
Yeah, this was start being built when I were doing my PhD thesis writings. I actually had quite a nice view. My view would have been completely blocked by these buildings. I escaped in time. And as for you who haven't heard of the company, we are a sodium-ion battery developer. So this will be a presentation a little bit more niche than the big companies, and maybe inside perspective on our journey, because we have heard here today talking about the industry, about the universities, and then the funding agencies, how they collaborate. But what happens when you want to go from university to industry? Industry is very good at developing their products, but sometimes new quantum leaps in technology is discovered at the university, but how to commercialize them. And we have done this journey partway. We started here at Uppsala University. And when starting a company, you need basically three things. You need people, you need an invention, and you need money. And the invention is from Christina Edström's group here, the structural chemistry group, who do a lot of research on batteries. And this is a future battery technology for sodium ions. And if you focus down on the chemistries tomorrow, why are we doing this research? So it has been mentioned, the scarcity of raw materials, the price fluctuations when the supply chains gets restricted, or when countries go in and regulate export by law. And the issue of cobalt has been prominently featured in papers the past few years. But even if this wasn't a problem, just looking at the raw material chain, the need for batteries is scaling up faster than we can scale up the production and expand this material increase. So even if we would do as fast as we can, we would hit a roof when lithium-ion batteries cannot provide the whole battery market. And the chemistries of tomorrow is to basically help complement lithium in this in markets where the highest energy density is not needed. We do see from 2018 to 2030 a 14-fold increase in battery usage. So like how to make that possible. And the way is to use abundant materials. So if we look at a periodic table distorted after how abundant each element is, we want to go for the big elements, and preferably not the critical ones that lithium use. And even though some of these can be seen, if you can read the letters, it means there's probably a lot of it on the earth. But the part of the lithium is like the economically availability. You can find a lot of it in the oceans, but you can't really purify it at a reasonable price. So one of the chemistries that were being done research on here was a Prussian blue analog called Prussian white. The interest was sparked in the group partly because John B. Goodenough, he was featured in a picture earlier today as one of the 3 Nobel Prize winners for lithium-ion batteries. He published a paper on the material he called Prussian white, a highly sodiated defect-free Prussian blue analog, which gave the equivalent performance as to a lithium iron phosphate chemistry. So it could be in the same ballpark as lithium batteries, but using only abundant materials that could be sourced from anywhere in the world. So we have the 3 inventors of the company. They looked at the Goodenough paper, which used a pressurized boiler to make this material, but they only made small batches at a time, spending a lot of time making this synthesis. And this was for Ronnie's PhD, and he were doing on polymer electrolytes. So he just needed a cathode to complement his research. but he spent a lot of time synthesizing the cathodes. He tried the other cathodes, but they were binary. Either they worked or they didn't work. But the Prussian white system, it always gave some capacity. So they're like, okay, let's look into this. They said he and his supervisor, Reza Younesi, sat down with William Brandt and discussed like how to make this in larger volumes and came up with the solution of acid decomposition. And Ronnie got his material and everyone was happy. Then this became forgotten for a few months because at the university, we are really good at solving problems, mostly our problems. And then we forget if we had a problem with it, maybe someone else had as well. So this took a bit of a turn when Adam Dahlqvist was here presenting InnoEnergy, part of the innovation system around universities, which helps bring research out into reality. He presented InnoEnergy at the structural chemistry group meeting and what they can do to support such a road. So Reza Younesi was like, maybe this discovery we had was a good one. Let's ask Adam what he thinks about it. So Adam takes this idea to evaluate if it's something good. And to understand the benefit of this technology, we need a quick crash course in production of sodium-ion batteries, or lithium-ion batteries in this case. You have a layered structure where you have two current collectors. You cast your electrode on top of the current collectors. You stack them with a separator, and you put it into a can and fill it with electrolyte and seal. And this is important because this is the same way that the sodium-ion technologies is manufactured. Because if you want to help alleviate the raw material chain for lithium-ion batteries, you do not have time to build up an entire industry to support the production of your battery. But this was a drop-in solution to existing infrastructure of battery manufacturing. So with this, they saw a battery with no NMP and fluorine-free. To reduce fluorine chemistries is also one of the sustainability goals of the European Union. You had safe batteries, which is kind of good when you want to put them into buildings or where people live. And you have none of the scarce materials used in this. So with such a good idea, with such a great potential, Adam thought this was a really good thing that should be promoted. So he couples the researchers together with Paul Larsson to help complement the experiences to build a company, because there's a lot of knowledge required to actually move this on forward. So 2017, Altris is founded and joins the Inno Higher Way program to commercialize this idea, and Inno helps patent the process. And patents is a really good thing when you start promoting to investors why they should pay for your company. But even though the initial ideas were done, it needed to be proven further. So we got some funding from Vinnova to take this outside of the university. And we went to a collaborator here in Uppsala called Lifesize to make the first prototype cells. And then in this case, I were employed as the first employee to help move out of the university. But this required several parts. It was scaling the synthesis. So you needed to have the chemistry and the chemical engineering to do that. We're also manufacturing the batteries and evaluating that. And this is a simplification on how you cast it onto the electrode and dry it in the oven. But the battery process contains several steps. You can be a specialist in every one of these steps and do research on it. But here we needed to do everything on our own. And these are all interconnected, so you need to see how they affect each other. But apart from doing this, we actually needed a physical place to be. So you do manual labor, building walls, setting up your research facility. But after some hard work, we actually got our first batteries that were 1 amp hour big, which became the foundation to actually promote the company to get private money. Because there is still a gap in between what Energimyndigheten and Vinnova calls research and what private investors calls research. So the investors want to see a higher maturity than Energimyndigheten before they are willing to pay. So we needed a way to bridge this gap. to get the money needed to do this, because you don't have funding to pay for these things. That's usually private equity that you need. And the way to bridge this gap is usually to build trust around the idea. So you need to build a really comprehensive business model to explain, like, what are you doing? How does it fit into the whole? Because the batteries are only part of a whole for an end user. If you're going into a battery pack in the building section, then you need to have a lot of companies involved. You need to thoroughly explain how you will get there. And you also need to have a really good plan forwards, like when will you be self-sufficient? And you need to really convey the message that this is a plausible way to go to bring on the private investors, but they still wouldn't join if it wasn't for the public funding that helps take part of the risk, because it's a lot of risk involved the more people or companies that are involved in the same project. So the thoughts from this journey is that people make a big difference in small companies. So for the recruitment part, it hasn't been such a big issue for us to attract talent, because we do think that we are doing a difference. So we have really motivated people that actually wants to do a difference. But we need super generalists. The smaller the company, the bigger the need for auxiliary competences, because we cannot afford, the smaller you are, the less you can afford to be a specialist doing only one thing. And one of the big mindsets we needed to change from the university is that we can't go for perfection. You can polish something until it shines and still polish it some more after that. But if you want to go out into the market, you need to find where's the level of good enough and push for that. And you also need quite an open mindset and flexibility for how the working day would see, because when you're in a growth company, your environment will change from day to day, and your working tasks may change with them. So with that, we can take some questions, but I also would like to thank everyone that's been part of the journey so far, because going out from the university is rarely something you do on your own, and we've had a lot of support along the way so far. Thank you.
Thank you very much, Tim. We have the room for a question or two. So we have one question here.
Hello, my name is Jonas. I'm a PhD student at structural chemistry here, and do research into sodium-ion batteries. I want to ask, where do you think your company is in 5 years?
I mean, 5 years, we have a pretty good grasp. Things takes time. 5 years now is basically what it would take to build. We have planned a factory that would be basically half the cathode production needed to supply a Northvolt level of Skellefteå. And that's a 5 years project. So basically we would be, if everything goes according to plan, where Northvolt are today in 5 years. Maybe not with only looking at the Swedish part.